Okay, so this is part three in our mechanics. The last time we did we look at position time graphs in details and the different scenarios. Again, just to recap, when you plot position against time, okay, the 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 slope or the line you get um, represents the velocity. Okay, so the slope of the line or the slope of the curve um, represents the velocity. Okay, so again, a straight line tells you that you have a constant velocity. Okay, if the line is steeper, it suggests that it's a faster velocity. Okay, when you have a line going from left to right, then it tells you that, and you do your slope, and if you get a positive slope, then it tells you that it's a motion from left to right. With a negative slope, or if the curve slopes downwards, it tells you that it's a motion from right to left. Okay, so these are all the different scenarios in that you can uh, you know describe with your position time graph. So now we're going to move on to velocity time graph. So you can plot your velocity against time, and you're going to get some graphs. So it's important to understand the velocity time graph just like you did with the position time graph or the displacement time graph. So let's look at these different velocity time graphs. So if you look at your velocity time graph, you have a positive and a negative. Again, when you have a positive velocity, it suggests that you have a motion from left to right. When you have a negative velocity, it suggests that you have a motion from right to left. So that's what this means. Or positive velocity, something moving upwards, a negative velocity, something moving downwards. So try and understand that, there's nothing magical about these graphs. They tell you exactly what's happening. Okay, and it's not a complicated exercise. It's relatively straightforward. So again, so your positive velocity, which is on top, tells you that you have a motion going to the right or something going upward. So if you have a rocket, if you have a rocket uh, going up, you would represent it in a positive uh, domain of your velocity time graph. And then if the rocket is coming downwards, then you put it in your negative domain. So again, so if you look here where you have your time on the horizontal axis, the velocity on the vertical axis, and then if you look at this straight line, so you have a velocity time graph and you have a straight line. So again, the slope of your velocity time graph is your acceleration. Just like when you had your position time graph, the slope is velocity. So the slope of your velocity time graph is acceleration. Remember, you only get acceleration when you have change in velocity. So let's look at what's happening in the top portion of the graph. Okay, so again, positive, which is on top, suggests that you have motion to the right or motion upwards. So a straight line, okay, in your velocity time graphs tell you that you have positive acceleration, because when you do the slope, you get a positive number, okay? So it's slope upwards, so it's a positive number. So the slope of your velocity time graph is acceleration, because you see if you once you plot time against velocity, as time increases, the velocity is increasing. As time increases, the velocity is increasing. So the definition of acceleration, change in velocity. So the velocity is changing, but it's increasing. So because the slope is upwards, the positive acceleration. So if you look on this flat portion of your velocity time graph, time is moving, but velocity remains the same. So therefore, the velocity is zero. It's not moving. If there's no velocity, you have no acceleration. Or there's no change in velocity, there's no acceleration. Okay? Sorry. Um, no, sorry, I made a mistake right here. This this is your zero velocity. This is not zero velocity. This velocity is about 1.5. So this horizontal portion, your velocity is 1.5. It's about 1.5. So as time increases, the velocity remains the same. So this is a constant velocity. The velocity is the same as the time increase. So this is a constant velocity, so you have no acceleration. As opposed to this line on the bottom, where it represents zero velocity. So you have your velocity is zero, and there is no acceleration because there is no velocity. Okay? So again, this flat line right here, there's a velocity number associated with it, but the velocity is constant. And you see, at this time, the velocity is this number. At this time, it's the same number. At this time, it's the same number. Same number. Same number. So the velocity is constant. It's not changing. So if there's no change in velocity, then you have no acceleration. And then this portion of your curve, it slopes downwards. This is sloping downwards. So that's a negative acceleration. Okay? So because remember the slope of your velocity time graph is acceleration. If it slopes upwards, then this is a positive slope, positive acceleration. If it slopes downward, then this is a negative acceleration, okay? And then this is your zero velocity, no velocity right there. So now we come down to the negative portion of your velocity time graph. The negative portion is right there. Remember what we said about negative velocity. Negative velocity tells you that you have a motion from right to left. It's going towards the left, or it's something coming down. So if something is coming down or it's moving to the left, we assign it a negative number. You can see that this slopes downward. This slopes downward. So the slope of your velocity time graph is acceleration. So if it slopes downward, it's negative acceleration. Okay? So you can say this is negative acceleration because it's sloping downwards. But look here, the velocity is increasing because at this point it is one. Okay, so at 1 meters per second, it's right there. 2 meters per second, it's there. 3 meters per second, it's right there. So even though you have a negative acceleration because the slope is negative, the acceleration is actually increasing. Sorry, the velocity is actually increasing. It's just that it's moving to the left or it's coming down. So remember, the negative sign just tells you the direction of travel. Okay? The negative sign gives you the direction of travel. Negative means something is coming downwards, or it's moving to the left. And then this is your slope of your velocity time graph. It's moving, its slope is downwards. Slope is downwards, so it's a negative acceleration. So if you look at this straight line, so at this straight line, as the time increases, the velocity remains the same. So it's a constant velocity, even though it's moving to the left or coming downward. It's this constant velocity. If the velocity is constant, you're not going to have any acceleration. You need to have a change in velocity to have acceleration. And then this is a positive slope. Okay, this slopes upwards. It slopes upwards. So the slope of the velocity time graph is your acceleration. But if you look here, the number actually is decreasing. So you have 3 meters per second, then it's gradually. So the velocity is decreasing, but you have a positive acceleration. Okay? The velocity is decreasing, but you have a positive acceleration. All right. So again, so let's look at it again. So velocity time graph. Okay. So as the time, so we're in the positive portion. So it's positive. So there's a motion going to the right or something moving upwards. Okay. You're driving a car to the right, or you're in a rocket which is moving upwards. Okay. So as time increases, the velocity increase. So a straight line in a velocity time graph tells you that the acceleration is constant because the slope of your velocity time graph is your acceleration. And the slope all along here is the same. And then when it's horizontal like this is constant acceleration because, okay, if you take 3 seconds, velocity is 4 meters per second. 4, the velocity is still 4 meters per second. 5 seconds is the same. So the velocity is constant. So even though you're increasing your time, the velocity is the same. So if you have constant velocity, you're not going to have any acceleration. For you to get acceleration, you have to have change in velocity. And then the curve slopes downward like this. So this is negative acceleration. And we call that deceleration. Okay? So negative acceleration right there. But what happens when you're right there? Okay? So this is in the negative portion of your velocity time graph. So the acceleration would still be negative, okay? But the direction of travel would change because now you're in the negative portion, the velocity is going to be negative. So instead of moving to the right, you're moving to the left. So you're moving to the left with a negative acceleration. Okay? So again, velocity time graph. So if you're in an aircraft and the aircraft takes off, when the aircraft takes off, you have rapid steady acceleration. Okay, so this bright line would represent your rapid steady acceleration. Okay, so as the time increase, the velocity increase, and it's moving upwards. It's moving upwards. Okay, as opposed to if you're in a train and the train is moving, let's say 30 miles per 30 miles per hour with a constant velocity. If it's moving 30 miles per hour, going to the right, okay, because remember it's positive. If it was moving to the left, it would have been down the bottom. So it will be negative. So it's moving to the left, but the velocity is constant, hence there is no acceleration. Okay? So the aircraft, when the plane takes off, the plane takes off very, very quickly, extremely quickly. So you can see that the slope of this velocity time graph is very steep, as opposed to this race car. The race car is not as fast as the airplane. So when the aircraft, when the race car takes off and it's speeding up, it is speeding up quite, rapid, but it's not as fast as the aircraft. And that is why the velocity time graph for the aircraft is much steeper than the race car. Remember, the slope tells you about the acceleration. So there is much more acceleration with the aircraft than the race car. The slope of the velocity time graph tells you about acceleration. Okay? All right. And then if you have a curve like this, okay, then again, the slope, it starts, so the slope of the velocity time graph tells you about the acceleration. So just look at the slope. So the slope is not very great, and then it gradually increase. So this is increase in acceleration. It is a positive curve because it curves this way. Okay, but look at the slope. You can do the slope at each point, and the slope actually gradually increase. So this is increase in acceleration. Again, the slope of the velocity time graphs tell you about acceleration. And then this one is something that's slowing down because it's a negative slope. So negative slope, so it's sloping downwards, so that's a negative acceleration. Negative acceleration tells you that it's slowing down. Okay? So go over the different graph scenarios and you should be able to describe the motion. Again, this is a very accurate way of describing motion. And you can do a written description, but when you put it on the graph, you need few words to describe it. Someone looking at the graph know exactly what the motion is. Okay. All right. So again, you look at the velocity time graph. This is not a very steep. This is not a very steep curve. So it's this acceleration. It's slow acceleration. Then it gets steeper. So quick. So you can see that this is steeper than that. So accelerates quickly. Okay. All right. So it's accelerate quickly, and then you have a flat line or horizontal line. So again, the flat line means that the velocity is not changing even though time is increasing. So this is constant velocity. Then you have a negative acceleration because it slopes downward. And this is very steep. This is very steep. So this is rapid negative acceleration or rapid deceleration. And then you the motion is horizontal. The motion is horizontal, but the motion is horizontal at zero velocity. So if the velocity is zero, that means it's not moving. So it stops. It stops right there. Okay? So the difference between this horizontal line and this horizontal line is that this is at zero velocity, whereas this has some velocity. So that this means that the motion or what the object stops. Now you're moving into the negative. So remember, this is positive. Negative velocity move, that means that you're traveling in the opposite direction. Negative velocity move means that you're traveling to the left or something is coming downwards. So and then the slope tell you about the acceleration. So this is sloping downwards. So this is negative acceleration. Okay? Negative acceleration. But be careful. Negative acceleration because it's sloping downward, but the negative number for velocity is going to increase because you'll have, say, you'll have probably -1, -2, -3. The minus just means that the direction of change, but because the number is increasing, that means the car is speeding up, or the whatever object is speeding up. So try and get that concept. The only reason why it's down in the negative territory because of the direction change. Okay, direction change. The object is coming downwards. Something dropped from the sky. Rocket is coming downwards. Um, Something is dropped, but the numerical number is increasing, so that means it's speeding up. So it speeds up in the opposite direction, and then a flat line again means, but there's a number. So even though it's moving in the opposite direction, this is a constant speed, steady speed in the opposite direction. So negative number just mean opposite direction. You still need to say whether it's speeding up or what it's doing. Okay? All right. So let's look at these scenarios. Um, all right. So object at rest. So the first one is an object at rest, velocity time graph. If the object is at rest, then it's going to have zero velocity. If the object is at rest, it's going to have zero velocity. Okay, so that's this, so you'll sort of brighten this zero line, tell you that there is no velocity, object is at rest. Then this is the object moving at constant speed. So there's a numerical value to the velocity, but it's a straight line. Okay, remember the slope of your velocity time graph is acceleration. There is no slope here, so there is no acceleration. And then the next scenario is constant acceleration. Velocity is on the vertical axis. Time is supposed to be time on the horizontal, and then you get a straight line. So this is constant acceleration. Okay? And then this is negative, so velocity, time. This is negative acceleration because the slope downwards. This is positive acceleration. Okay? So remember, the positive portion of your velocity time graph tell you that the motion is to the right. It's moving to the right or upwards. Okay? So even though this is still motion to the right, it is a negative acceleration. So this would be a scenario where you're driving to the right, but you're applying your brakes. Okay? So a negative acceleration means deceleration. Okay. And then look at this. This one is varying acceleration because the slope, again, the slope of the velocity time graph is acceleration. So it's gradually changing. So the slope right here is fairly steep. Okay, so you have the acceleration was pretty fast, and then the acceleration gradually you're reducing the acceleration, and then to right here is almost flat, so you'll have constant velocity and no acceleration. And then in this one, in this scenario now you have velocity time. You can see it starts out, the slope is not very great, but the slope actually increase as time goes. So the acceleration gradually increase. Okay. All right. So you should be able to describe each velocity time graph accurately. Um, so another important point is, you know, how steep the line is. That is the gradient again. How steep it is on the velocity time graph tells you the acceleration of that object. Again, the steeper the line, the greater the acceleration. Okay, so again, you have a positive acceleration, constant velocity, no acceleration. Then you have a negative acceleration. So it's best to use the term positive and negative acceleration. That accurately describe what the motion is. And then when you move to your negative velocity, it tells you that you're moving in the opposite direction. So instead of moving from right to left, you're going to the left, or something is coming down. It, it's coming downward. The acceleration is a negative acceleration because the slope downward, right? It slopes downward. But the velocity is increasing. The negative number is increasing. Remember, the negative number only tell you the direction. You can see that you move from 10 to 20. So this is if this was a car, the car changed direction from left to right and now going from right to left, okay? And it is speeding up but with a negative acceleration. And then at this point, this motion would be, it's still in the negative velocity portion. So it's still moving to the left, but you can see the acceleration is now positive. It's positive acceleration. Positive acceleration because you have a positive slope, but you can see that the velocity is decreasing because you now move from, say, probably minus 20 to minus 10. So the number is decreasing. So it's slowing down. It is slowing down, but the acceleration is positive acceleration. Okay? Again, the steeper the line, the greater the acceleration because the slope of the velocity time graph gives you acceleration. And again, acceleration is measured in meters per second square. All right. Now, it's very important for you to appreciate that, you know, when you have a velocity time graph, the velocity is on the vertical axis time. Again, the slope is the acceleration, but the area under the curve is tells you about displacement or distance traveled. We're talking about vector quantities, so let's stick with displacement. The area under the curve. So if they ask you to get the displacement, say between 2 seconds and 4 seconds, if they ask you to get the displacement between 2 and 4 seconds, you complete the right angle triangle and you get the area under the curve. Area under the curve. So this even though we said area under the curve, this is a triangle. So what is the area under this curve right here? Okay, the area. Remember, the area of a triangle is half the base times the height. So the area of the area under the curve, gives you displacement or distance. We're going to come back to that, but try and remember that. All right. So the area on the velocity time graph gives you distance traveled. So, all right. So you have, so this is velocity, this is time, okay? We know that the slope is the acceleration. The slope is the acceleration. So we have the speed, we have the time, but we don't know the distance traveled. What I'm telling you, if you want to find the distance traveled between 0 and 5 seconds, you just come up 5 seconds, and the area on the disk curve is the distance traveled. Again, the area of a triangle is half the base times the height. Okay? So the area of this triangle is half the base times the height. You're going to find out that this is very extremely important when we're talking about mechanics and motion. Because if you know the speed and you know the time and you plot it for a moving object, you can calculate the distance traveled, okay, by just half the base and multiply it by the height. So the height is the speed. So at 5 seconds, the speed would be, say, 50 meters per second, and then the base would be 5 seconds. Okay, so that will give you the distance or displacement traveled. Okay, very important. So you need to get this concept straight. So we're going to talk a little bit about free falling objects. So one of the things mechanics allows us to do is to evaluate free fall. So when we talk about free fall, we're talking about if you drop an object or something fall from a certain height. We make a number of assumptions though. Okay, when we say free fall, we talk about an object that is being acted upon only by the force of gravity. So again, if you're unfortunate and you fell out of an airplane, I mean, that's close to free fall. Okay, because the definition is an object that is being acted upon only by the force of gravity. It is not completely accurate because you have air resistance. So when you fall out of that airplane and you're coming downward, there's something called drag that's going to try and lift you up because the hair have, a sort of resistance to it. So, but what we do, we assume that you're not going to encounter any air resistance. So, that is one of the assumptions that we make. So when we talk about a free falling object or object subjected to free fall, what we're saying that the only force that's acting on that object is the force of gravity. We say that the air resistance is negligible. A couple important points: the moon is in free fall, but the centripetal force, keeps it moving around Earth. But the moon is in free fall. The Greek philosopher Aristotle, 384 to 322 BC, was the first physicist to discuss falling objects, and he had one of the first book on mechanics. And then later, the Italian scientist Galilei Galilei in 1564, 1642, he tested the Aristotelian theories and came up with some mathematical analysis. So what you need to do is read up about Aristotle and Galileo, but you know there we have improved on those theories. So when something is subjected to free fall, again, the only force acting is the force of gravity. So acceleration of gravity is the acceleration of objects on the free fall close to the surface of the earth. So close to the surface of the earth, if you fall out of a airplane, you're close to the surface of the earth. I mean, you're not out of the orbit, so you're fairly close to the surface of the earth. So if you fell out of a airplane, you're going to be subjected to the acceleration of gravity. Okay, so you're going to be pulled towards the center of the earth. Okay, and again, what is acceleration? Again, remember, acceleration is change in velocity with respect to time. You cannot have acceleration unless you have change in velocity. Okay, acceleration is change in velocity with respect to time. So when you have a change in velocity, we talk about final velocity and initial velocity. So if you fell out of the plane, I mean, just as you start falling out, you're going to start, I mean, zero. You're going to be stationary, and then if they kick you out of the airplane, then you're going to start falling. And then just before you hit the surface, you'll have um, a terminal velocity. Okay, so we all right. So yeah. So if we assume that when you have a free fall, we or if you're dropped, say you drop something or you fell out of the airplane, you probably don't have you're not going to have an initial velocity. So if you have a ball in your hand and you drop it, the initial velocity is going to be zero. So the acceleration is equal to the final velocity over time. And when we calculate it for gravity, it's equal to 9.8 meters per second. So what this is telling you is that for every second, so remember the negative sign just means that it's moving downwards. Remember, negative sign means it's moving downwards. So it's a negative acceleration. So it's moving downwards. So this acceleration of gravity or the acceleration due to gravity is a change in velocity. Change in velocity, 9.8 meters per second. So this is the velocity, 9.8 meters per second, every second. So every second, the velocity is going to increase by 9.8 meters per second. Every second, the velocity is going to increase by 9.8 meters per second. And again, as we mentioned, it's altitude dependent. Close to the surface of the Earth, it is 9.8 meters per second per second. Okay, it's altitude dependent, and the symbol we use is G. Okay. Now, the acceleration of gravity varies depending on where you are, because remember, it is the pull. It is that pull towards the center of an object. We talk about the center of Earth, but I mean that's just the acceleration due to gravity of Earth. But if you were at the North Pole, I mean, still on Earth, the acceleration due to gravity at the North Pole is 9.83 meters per second square. If you're at the equator, it's 9.78. If you're at Mount Everest, it's 9.76. The Marianas Ocean Trench, 9.83. International Space Station, 9.08. Okay. However, on the surface of the Earth, okay, it's 9.8. Okay. So the further away from the surface of the Earth it gets, less. Gravity is less the further away you are. On the moon, so if you want to have a very low acceleration of gravity and weight, then you can go to the moon where your weight will be, probably one tenth, close to one tenth of what your weight is on Earth. So the acceleration due to gravity on the moon is 1.64 meters per second squared. On Mars, 3.72, still low. On Jupiter, it's tremendous. So if you don't like to be heavy, don't think about going to Jupiter, because your weight will be about 3 times what it is. Okay. Um, all right. So just for an example, if you have a mass of 63.5 kilograms on Earth, your weight would be, 623 newtons, for 140-pound person. If you're on the moon, you wouldn't have much weight, because remember the acceleration due to gravity, and we'll show you how you get that. Okay. Um, the acceleration due to gravity, um, on the moon is very, 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 uh, much less than what it is on Earth. So you weigh only about 103 newtons, or 23 pounds, negligible weight. On Jupiter, you're going to be a little bit bigger, even though your mass is still the same. You're going to have a weight of 1582 newtons, or 355 pounds. Okay? As opposed to if you go to the sun, you're going to weigh 3,000, you're going to weigh pretty close to 4,000 pounds. So even, your weight is going to vary, depends on where you are. I mean, fortunate for you, you spend most of your time on Earth, so your weight is going to be, on the surface of Earth, so your weight is going to be relatively fixed. But if you're traveling all over the universe, your weight is going to vary. So, um, so again, when we talk about acceleration is the rate of change in velocity. So when we talk about an acceleration of 9.8 meters per second square, what we're saying is that the acceleration, change in velocity, is 9.8 meters per second every second. So every second, the velocity is going to increase by 9.8 meters per second. Okay. Um, so again, acceleration, change in velocity with respect to time, final velocity minus initial velocity divided by time. Um, Again, acceleration due to gravity, 9.8 meters per second square. It's You're supposed to put a minus sign before it. It tells you that the motion is downwards, the pull is downwards. That means for every second an object falls. So if you drop an object, for every second that the object falls, the speed increases by a factor of 9.8 meters per second. And of course, we ignore air resistance. So this is what we talk about. So if you're right up here and say you drop a ball, up here. So just as you drop the ball, or just before you drop the ball, at time 0, the velocity is going to be 0. But at time 1 second, okay, at time 1 second, the velocity is going to be 9.8 meters per second. At time 2 seconds, the velocity is going to double, because remember what we said, every second the velocity is going to increase by 9.8 meters per second. Acceleration, remember the acceleration is change in velocity. It is 9.8 meters per second, which means every second the velocity is going to increase by 9.8. So at 1 second, 9.8, 2 seconds, 19.6, 3 seconds, 29.4, 4 seconds, 29.2, and then at 5 seconds, 49.0. So every second, the velocity is going to increase by the acceleration number. So that is why the units of acceleration is the unit of acceleration is meters per second squared. Meters per second squared. So the velocity is going to change by a certain amount every second. Remember velocity is meters per second, and it's going to change by a certain amount every second. But when you're talking about free fall, and the acceleration due to gravity is 9.8 meters per second squared. Every second, when you drop an object, t0, v0, the first second, velocity is going to be 9.8 meters per second. The second, it's going to be 9.8 plus another 9.8, so 19.6. So every second is going to increase by 9.8 until it hit the ground. So that is what when we talk about free fall, the only force acting on the object is the force of gravity, acceleration of gravity. So the speed is going to change like that. Every second, it's going to change by 9.8 meters per second. And then we have a lot of mathematics we can work out. But we're going to leave it right here, and then the next session we will